Um, so if you haven't already, please look over. This is number 23 that I have on screen. I'll scroll down to 24 here in a second. And as you guys have questions, just kind of leave them in the chat and I'll go over them. Yes, you will have homework. I'm not going to explain it until a little bit further in, though. So, any questions on 23? The actual answer is negative 70. KJ was right. 20 minus 90 is negative 70, not positive 70. Yes. Yes, it matters which numbers you multiply and add first. All right. This is number 24. Again, go ahead and just take a second, check your answer over. And as you have questions, just kind of post them in chat and I'll answer them. We will have some kind of test. I haven't decided what that looks like. I'm going to talk to the math department and see what they kind of think. And I've been talking to a couple other teachers right now. Um, it will look different. It will be different. But yes, in some way, shape, or form, we're going to have a test. Okay. Questions on 24. All right. For today, it didn't matter as long as you actually tried to submit something to on campus because that's how we're going to do it from now on. I screwed up. I didn't make it so you could, or I made it so you couldn't submit more than one thing, and a lot of people had several different pages. If that's the case, then that email's fine. But as long as you try to submit something, that's what I'm trying to get you guys to do from here on out, or as long as this lasts. Okay. I did want to do 25 kind of in front of you so you could actually see the process if you were confused. Um, so this is number 25. Uh, you still go about this the same way, even though there is a 0R right here. Um, I'm going to eliminate S in this case, right? So I'm going to take the second 2 and just eliminate R. Or eliminate S, I'm sorry. And then I'm going to take the first and second. And I'm going to eliminate S in the same way. So I need to multiply the top one by a -2. And when we do that, we still have 0R plus 2S plus 8T is equal to 18. Okay, any questions about what I have on the screen so far? So this is eliminating it to get down to a system of 2 equations from a system of 3. All right, now we just have to solve the system of 2. And in order to do that, we need to multiply the top one by 2. When we do that, we get 2R plus 20T is equal to 54. And then we just add down. After that, we just plug this into one of our system of two equations. So I'll pick the top one. And then solve for r. And then once we solve for t and r, we plug both of those into one of the original three. In this case, I'm going to pick the first one, just because that's a little bit easier to work with. So we have 0 times -3 minus s minus 4 times 3, and that should be equal to 9. And after we do that, we just solve for s. And then we solve that system. Are there any questions over this elimination part? So that's the first part of the homework. Are there any questions over that? Okay, the second part was to take the determinant of the coefficient matrix. So the first thing we need to do is we need to get the coefficient matrix, which is just the coefficients of r, s, and t. So those coefficients are 0, -1, and -4, -2, -2, and 5, 3, 2, and 5. And we need to take the determinant of that. And the first thing we have to do is to repeat the first two columns. And then multiply the diagonals, and then subtract them in different directions. Okay, so our top would be 0 times -2 times 5 plus -1 times 5 times 3 plus -4 times -2 times 2. And then our bottom part would be 3 times -2 times -4 plus 2 times 5 times 0 plus 5 times -2 times -1. Are there questions about that process before we actually get a number? Okay, then we just subtract that top part from the bottom part. So up top, we have 0 minus 15 plus 16. That's just 1. And then we want to subtract that with 24 plus 0 plus 10, which is 34. So 1 minus 34 is -33. Are there questions about any of that or anything on the homework? So in order to submit pictures, what I would do is take a picture with your phone and email it to yourself, and then download that file on your computer and upload that. Um, there is a way to do it on your phone. Like if you go to on campus and hit submissions, there should be like if you do all that on your phone, you should be able to submit something from your phone. I think it just might be easier to do it on your laptop though. Okay. This is what I would expect us to be able to do, at least as of right now. Okay. So if there are any questions, we need to ask those in the next couple of days because we are going to plan on having a test. Um, if that's late next week, it could be late next week or it could be early the week after. All right. So we do need to know this stuff. So please, if you have any questions, ask them. And if there are none, we're going to move on to Cramer's rule. Okay. And Cramer's rule kind of takes everything that we've just done and puts it all together. So this that you see is Cramer's rule. So if we have a system of three equations or two, or really any, it could be a 3 by 3, it could be a 4 by 4, it could be 5 by 5, it could be anything so long as it's a square number. Okay. Um, in this case, it's just a 3 by 3 system though. So if we have this 3 by 3 system, the first thing that we would need to do is to just get our coefficient matrix. So the coefficients of x, y, and z are a, b, c, e, f, g, I, j, k. Then we would need to take the determinant of this matrix. And that determinant of that matrix would be the denominator of x, y, and z. Okay, so the first thing we do from our system of three equations, we get the coefficient matrix. We take the determinant of that coefficient matrix, and that determinant is our denominator for x, y, and z, or any variable that we're solving for. Okay, and we will do an example of this. But after we get that denominator, then we would take the determinant of these, what I call answer matrices. All right. So the difference in each of these matrices is that in our x, y, and z column, we are replacing our answer column with the column that we're trying to solve for. Okay, so in this x answer, our denominator is the determinant of this coefficient matrix. Okay, the numerator is the determinant of the coefficient matrix, but where we would normally have our x column, now we have our answers. Okay, when we're solving for y, yes, the denominator is still the determinant of a, our coefficient matrix. The numerator is the determinant of the coefficient matrix, but instead of having our y column, we have our answers. And then the same thing for z. In the numerator, instead of having our z column, we replace that column with our answers. Okay, so I'll give you like 30 seconds or so to write this down, and then we'll do an example of it, and then I'll let you get started on homework, and I'll ask a couple of questions once we get after that. So for example, say we have this system of three equations and we want to solve this using Cramer's rule. So first, if you do have a calculator, have it in front of you because it'll come in handy coming up. All right. We have this system of three equations. The first thing we need to do is to get a coefficient matrix. That coefficient matrix is just the coefficients of A, B, and C in this case. After we have that, we need to take the determinant of it. And our determinant, this will come out to negative 250. Okay. Are there any questions about how I got that? All right. So this determinant of our coefficient matrix, that is our denominator for A, B, and C. Okay. So on your homework, what I would expect you to do is to get the determinant of the coefficient matrix by hand. And then on this next part, you can use a calculator. But I do want to see this work that basically all the work I show, I want to see on the homework. Okay. So then we have to set up the rest of A, B, and C. And the numerator of A, B, and C will be the determinant of a certain matrix. All right. So in A, we have to replace our A column with our answer column. And I'll do those answers in red. So instead of -6, 1, and -2, we have 1, 10, and -16. And then everything else in the coefficient matrix is the same. For the B numerator, our matrix will be everything the same except our B column. Everything else will be the same. And then for the C matrix in the numerator, our C column will be replaced with the answers. And then everything else, again, will be the same. Right? So this is the work I would expect, okay? And then for A, B, and C, instead of taking each of these determinants by hand, you can use a calculator and get the numbers for them, right? In this case, though, just so we actually have answers, A comes out to 0, B comes out to -1, and C comes out to -3. Okay, so for your homework, you have to make this a little bit smaller. On your homework, I'm going to expect all of this work on the screen, all right? You have to get a coefficient matrix. You have to take the determinant of that matrix, which is everything from here up. And then you have to set up how you would get your solution for A, B, and C, X, Y, Z, whatever. All right. So then I would expect this setup. And then you can get those determinants of the numerator matrices on a calculator. Okay, and to do that, remember you go to second matrix, you edit a 3x3 matrix, you quit, you recall that matrix, or you get DET on your calculator, and then you recall that matrix. So it'll look something like this. Okay, so first, Tim's question, do we subtract the determinants of A, B, and C from the other determinants, -250? No, -250 is your denominator. So you're going to get a number here. So in this case, the determinant of this numerator, that'll come out to be 0. And then it's 0 divided by -250, which is just equal to 0. All right. On part B, this determinant comes out to be 1. And then our denominator, it comes out to be 250. And then our denominator is -250. So 250 divided by -250 is -1. And then on C, our numerator, our determinant of our matrix, turns out to be 750. 750 divided by -250 is equal to -3. Okay, so we're not subtracting, we're dividing. All right. Alex, are you grading the homework based on correctness? Yes and no. 1, I want to see you actually submit it, and 2, I want to see your actual work. Those are the 2 most important things. If you show all of this work and it's slightly off, I'm okay with that. For the test, obviously, it needs to be correct, but for the homework, I want to be able to see all of this work. How did you get 1, 10, and -16? Okay, so 1, 10, and -16, that's this answer column. And we replace that. So, okay, we have an A column, a B column, and a C column, right? If we're solving for A, we need to replace the A column with our answers. If we're solving for B, we need to replace the B column with our answers. And when we're solving for C, we need to replace the C column with our answers. Um, any further questions on this? Again, I would expect all of this work up on your screen. Okay. Since there are no questions, your homework is number 18 and 19 on that same worksheet that you did last night. Um, but I want you to use Cramer's rule in this case. So I'd expect all of this work that you see on your screen for number 18 and for number 19. All right. I made it so you can actually submit two things. So if you have two pictures, that's fine. Um, and yeah, that you're just doing number 18 and 19. You can find that both in the assignment. So I set it as a download for this assignment. And it is also in topics in the same place that you found it the last night. All right. 18 and 19. Okay. All right. If there are no further questions, I'll leave this open for the next 30 to 40 seconds. As you guys have questions, I'll answer them. If not, though, I will move to Teams. I'll start a meeting, and if you have any further questions, you can ask them there. All right? All right. Since no one has any other questions, I will move to Teams. I'll end this. Keep in mind that this is always available to watch after. So if you miss something or you just want to see something again, this is up as soon as I hit end. All right. So I'll be in Teams in the next minute or so. And if you have questions, I will see you there.